All right, that was an interesting little way to spend the program or spend the period. Uh, when you look in here, what we had gotten to last time, I had asked the question is why didn't this one work and why did the other one work? And the answer is this called the default constructor, even though we hadn't written one. So one was written that just initialized all of the variables for us. All right. So we could come back in and we could write write a constructor in there. But remember, what the rule is once we come in here and we say public dog, all right, and we say int, I'm sorry, it was a bool, and CF for can fly, int for height, and an int for weight. All right, so we can do that. Okay. And we could literally copy in the same code we had in animal. But do we really want to do that? I'm asking you that question. Do we really want to do that? A dog's an animal, right? Okay. So, I'll make sure I give you the right syntax here. So let me grab my little cliff notes here. So what we want to do is in here, not in here, in here. All right. We want to put in this constructor, but guess what? We don't have to put anything special in it except for this. Oops, what the heck happened there? Colon, base, CF, H, W. All right. That's the whole constructor. Now, remember, please remember this. You don't have to look, but please listen. If you write your own constructor like this, now then remember, it does not now recognize the default constructor unless you write it. You understand what I'm saying? So we still have to come back in here and do this. Public, dog, paren, paren. Sometimes people even just put them right there. It doesn't really matter. But now we have two constructors. All right. And what this is saying is go to the base class. What class dog is based off of? And let that base class handle can fly, let it handle the height, and let it handle the weight. In fact, if you put your mouse over base, notice what it says. Animal.animal, bool CF, bool H, I'm sorry, int H, int W. I believe that it wouldn't even matter. I mean, we could put in, if we wanted to, I would think it would just take A, B, and C. No, it doesn't want that. It wants the actual names. All right. So now that we've got that, let's save this and let's run it again. And I've got can fly is false, etc., all the other good stuff that was in here before. Okay. Now it looks like, let's just see what I had here because I don't remember. All right. So we've got this one, this one. How about if we put this in here? Phyto contents. And I'll even put the rest of the stuff on a new line. Plus Phyto.string. And here, notice I put Phyto in again instead of spike. See this? So I should have changed that. Now I'll say spikes or spike contents. Plus spike dot toString. All right. I'll come right back to it, but let's make sure it didn't break. All right, so there, spike contents, can fly, etc., and you'll notice it all works. I guess I've got one too many line breaks in there. But hopefully you can see. So Phyto contents, I shouldn't have a line break there, otherwise it would look okay. because it already is a right line. That's why I don't need those. Try that again. There we go. No, still didn't do it. So after the contents, I've got to put that in there. All right. And the takeaway from this is we have two different kinds of dogs that are being handled in two different ways. Now, we could write another constructor that only took, for example, can fly. Or we could write another constructor that only had height or weight or any combination thereof. As long as the signatures were different. All right? But I do want you to understand one thing. If you look up on the screen, please. If all I did, so let's say I would write another one in here. Don't write this. That's why I'm doing it longhand. But if I did this, is that valid? Yes or no, and why? Anybody? Is that valid?
Yeah.
Okay, how many say yes? Okay, one. Why isn't it valid? No, that doesn't matter. You can put them in the other order if you want. It isn't valid, but remember the first thing that the compiler does is it strips off, in both cases, it strips off the variable name. So it says, hey, you've already got a bool, int. You've already got one of those with that signature. So that's illegal. So just flipping those two, okay, can you get around that? Well, you could have done height, then weight, then can fly. So that would have been different. So you could do int bool. See what I'm saying? Because I've watched people do stuff, and I'm like, why would you even try doing something like that? Now, questions? All right. Let's just so you see this, we're going to make another class here. It's going to be very small. It's going to have almost nothing in it. But hopefully you'll see why in just a minute. Okay? So let's come in here and let's make another class. So I'm going to again right mouse click. And I'm going to do an add. And I'm going to add a class. And I'm just going to, I was thinking that, heard that outside before. I'm going to call it Robin. It's going to be a bird. In fact, we could even call it bird. It doesn't matter. Maybe that's too specific. So let's call it bird. That's fine. All right. And I think you'd agree with this. A bird's an animal. So we could go through the same stuff we just went through before. Okay? We could go through the same stuff. In other words, we could write this. I could write a parameterless constructor, or I could make a bird right now, and it would do the default stuff. You know all that. All right? And you also know, or you probably do, that some birds don't fly, although most do. Okay? So let's write those rather than going through that same stuff again. So we will put in public bird, paren, and then we'll just put in our curlies right there, and then we'll write the other one. Public bird, bool, again, CF, int h, int w, and just like we did before, colon, base, CF, h, w. Move this over a little bit. And what doesn't it like? Let's declare, oh, there's no body. There we go. And again, we could just, all we need are the curly braces, so. And it's the same thing as the other one. Does that make sense to everybody? It's the same thing as what we did with the dog. So again, we can come in here into our animal program, and we can come in and we can, in our program here, we can make two birds, just like we made two dogs. So I'm going to do that right now, and I'm going to take these two dogs that we have, and I'm going to comment them out. And I'm going to say bird. Oops. Now notice when I do this, see how that doesn't work? Because I'm trying to say bird, and I'm trying to instantiate a dog into a bird. That doesn't make sense. All right. So I'm just going to say new bird. I'm just going to leave it at Fido. All right. And Spike. That's fine. And I'm going to make another bird here. And I'm going to say true, that one can fly. And we'll say that for the height, we'll just say, I don't know, 7 inches. And for the weight, we'll say 2 pounds. Okay. And let's double check and make sure that it works. All right. Can fly, true for the second one, 7, etc. Everybody convinced, basically, that this works? There's one more thing I want to show you in this. Does everybody who is typing this in who wants it have it? All right. I'm going to go back into, I'll go back, I'll do dog first. All right. Remember over here, we said we had this thing. Remember that? And that was for an animal. Well, I'm going to come back again, and I'm going to copy that into dog. So I'm going to come in here, and I'm going to put that in. But I don't want it to say that. I'm going to have it say woof, woof. All right. So I'm going to save this. I'm going to come back. It's not going to show anything because it's the bird right now, right? So I'd have to uncomment my dog stuff that I made. But all I'm trying to show you is we just did an override. Not an overload, an override. We overrode the one from animal. And that's one of the reasons that, I mean, with what we had done so far, was there any reason to create a dog? The dog was exactly the same as an animal, right? And now we can come into bird and we can do the same thing. So I'm going to grab this code. I'm going to go into my bird.cs file, and I'm going to paste that in. And instead of saying, oh, the program is still running, and so I'm getting that error. And I don't know, tweet. All right. And let's run it. I guess we didn't call it, so I've got to call it. So inside of animal, not inside of animal, I'm sorry, inside of the program, after we create the bird, we'll do the, just like the ones we did before. So bird.speak. Okay, and it doesn't like something. We'll fix that. No, it's not bird. It's spike.speak. Spike.speak. Spike.run. And spike.climb. I think that was them. All right. So now let's run it. And notice it says tweet. It's not saying what an animal would say, which is the animal is talking or whatever we said. It's doing the specific thing for a bird. Were I to come back in and comment this out and uncomment that stuff and did the spike.speak It would say woof woof. Does that make sense to everybody? I know the example's kind of stupid, but is what we're doing here makes sense? All right. So the reason that you typically would come in and do an inheritance is you can define a class and have something in there that's in common, and then have other classes that inherit from it, and they can inherit everything they need to inherit, and they can change around anything they need to change around, and they can add anything they need to add. All right? Now, I don't know if there's anything special that birds do, but just so you see this, true or false, I can also come in here if I want to and say public void, I'll just say eat. Okay? And I'm going to say here console.writeLine, I am eating. Okay? So that's what I said. And I'm going to come back into my program, and for Spike, I'm going to say Spike dot eat, and you notice it recognizes it. All right? So if I run this again, I am eating. What I'm trying to get across to you with all this is this. All right? You oftentimes make a base class that other classes are going to inherit from. Think about it this way. Let's pretend for a second that we were writing an application for a bank. We might make a class that was called bank account. And we might put in things like the person's first name, the person's last name, their address, city, state, zip, their account number. But we could then, from there, we could inherit from there and make a savings account and a checking account and maybe an IRA account. All right? And guess what we can do? We can inherit from checking. So checking could have both an interest-bearing account and a non-interest-bearing account. So now we're going levels down and we're creating a hierarchy. Do you understand what I'm saying? That's how much of the software that's out there today is written. All right. Questions on this? Because there's two more things we're going to do. The first is this. Would you agree that I'm not talking about a parakeet, but I'm talking about a crow or an eagle or something that's out in the wild? Okay, would you agree that with something that is out in the wild, they're not domesticated? Would you agree with that? Would you also agree that most dogs are domesticated? I'm sure there's always, I mean, there's stray dogs. There might be a dog out on a farm that's not domesticated, but you get what I'm saying, correct? All right. So sometimes what you want to do is you want to make something and you don't want it to be a class. First of all, just so you're aware of this, C#, like Java, you can have only one parent. Did you hear me? So I can be a child, I can have a parent, I can have a grandparent, I can have a great-grandparent, I can have a great-great-grandparent, etc. I can do that, but I can only have one direct, all right, one direct parent, just so you know that. Who cares? What if I want more than one? The answer is you can do it, but you don't make a class. You make what's called an interface. So I'm going to show you that right now. Now, by default, you don't have to do this, but everybody does. By default, interface files, you start with a capital I. And that shows that they're an interface file. So technically, you probably never want to create classes that start with an I if you can help it. Because most people look at that, oh, that's an interface. Okay? So we're going to make an interface right now. How do we do that? We again right mouse click on the name, the name of our project. We choose add. Now we have to choose new item. And the second one down is interface. All right. And I asked you about being domesticated, so I'm going to call mine capital I, capital D, domesticated. So it's I domesticated. And we don't have to call it that. You can call it anything you want. And you notice the difference. It does not say class. It says interface. All right, so it should have opened that one up for you. Okay? Typically, what you put into interfaces, almost always, the only thing you put into interfaces is our function or method names. Names. All right? So I'm going to put in two of them. I'm going to say if you're domesticated, oh, what did I put in here? I think I put in pet me and feed me or something like, yep. So I'm going to put in here void. We'll call it pet me. And void feed me. Because most dogs, at least, you can pet. I don't pet my dog. She's real little, but she's real mean. All right? That's why she's not my dog. She's my wife's dog. All right. But we've got these two things in here. That's it. What you do when you make an interface is you're making what is typically referred to as a contract. What do I mean? You're going to find out in about 30 seconds. All right. Does everybody who wants this have this? All right. So I'm going to save because I haven't saved in a while. And I'm going to go back. I'll do the dog right now because the dog is domesticated. Now, I just want to show you something. Please don't type this. If we were doing this and we were using the Java programming language, if we were using Java, all right, what I'm about to type in, we would do it like this in Java. We'd have to say the word public. Oops. So we'd say public class dog, and then we'd say extends. That's what this dot or the colon does. We'd say extends animal, and then we would say implements I domesticated. That's how you do it in that language. That's the only reason I'm putting it in there, just so you see it. I think I spelled that wrong. I think it's TI, not IT. That's how you do it like in Java. That's not how you do it here. Here, to show this, all we basically have to do, not basically, all we have to do is put a comma in here and IE domesticated. Not IE, it's I domesticated, sorry. That's it. Now, I'm getting an error. Don't even look at the error. Can you guess why? Remember I said it was a contract? Does dog have a feed me? Does dog have a pet me? Right now it doesn't. As soon as I put those in, that error will go away. But what an interface means is you define some functions. You don't say how they're implemented. You just define the interface, and then you put the implementation in the classes themselves. So I'm going to come down here, and all I'm going to say, I'm going to make two of them. So first, public void feed me. Hey, I'm hungry. All right, that's all I'm putting in there. Now I still get the error because I still have one that I haven't put in. Now look, please look on the screen, everybody. You see where it says show potential fixes? This is that help that we talked about before. So if you look here, it says, well, do you want to implement the interface? Do you want to implement all the members explicitly? And I can put my mouse over it and it'll show me what it's going to do. So I could have had it come in there and it says, well, what's left? Well, pet me. See that? But it puts in there the name, the IE domesticated. So I'm just going to put it in there manually. And I'm going to say public void pet me. And I'm not going to have it say, hey, I'm hungry. But I'm going to copy that line. And it's like, hey, pet me already. Now, the reason I'm showing it to you like this is typically Bird would not implement that interface. Does that make sense to people? You know, you can reach, oh, I got a pet bird. I don't care. So if that's the case, then call it Tiger or something else. All right. But now I should be able to come in And I should be able to go back to my program here. Okay. And now I'm gonna comment all this stuff out that I just put in. And I'm gonna uncomment this stuff that I did for the dog. All right. Let's see. Oh, they still got the birds in here, so I got to uncomment those. Or comment those. All right. All right. Now this spike.eat doesn't work, and it doesn't work because that was something defined for birds. But now I can say spike dot feed me and spike dot pet me. Again, the order doesn't matter. All right. And if I save this and run it, hey, I'm hungry. Hey, pet me already. So typically the way you set this stuff up, is you come up with a generic type of class. And then you base other classes off that generic type of class. Does what I'm saying make sense? And if you've got extra stuff that would only pertain to some classes, you put it into an interface. Now, I'm being general. Not every book is going to agree exactly with the way that I put that. All right. There's one more thing I want to do in this program. And that is, I think you'd all agree with this. Let's pretend for a second that you just got a new pet. All right. You with me? You just got yourself a new pet. All right. And if somebody says, so Gabriel comes up and says, hey, I just got a new pet. I'm going to say, what is it? And he says, it's an animal. Well, if it's a new pet, I was kind of think it's an animal. My next question would be, well, what kind of animal, right? That kind of thing. So what I'm telling you is animal is actually so generic. This is so generic that I'm probably never, I don't even ever want to make an animal class. I don't really want to do that. And if I want to, then I could say this. Now this is going to break some of the other code, but I can say abstract. If you make a class abstract, it cannot be instantiated. Did you hear me? So for instance, next week, we're going to be starting to work on a bank account class. What kind of account do you have? I got a bank account. What kind? It's a bank account. All right. That's too generic. So typically, like, and a lot of times you'll see this animal, or they'll make it mammals, or if you're using shapes, you'll make shape, and then underneath it you'll have triangles and rectangles and squares and ellipses, etc., that kind of thing. So did it break anything in here? Nope, doesn't look like it. All right, but if I come back to this, to in here, you think it's going to break if I uncomment this stuff? I'm trying to instantiate an animal right there. See that? It's breaking. If I put my mouse over it, it says, cannot create an instance of an abstract type. It doesn't work. You can't do that. And notice it's not breaking here. So what if I tried doing this? What if I say animal, animal equal new dog? Oops. That looks a little weird, doesn't it? But guess what? That's legal. If you set your classes upright, basically the parent should be able to do anything the child could do except for the special stuff that you gave the child permission to do. All right. Sometimes there are reasons you might want to do that. I don't want to get into them right now because it gets to be a little hinky, for lack of better words. But if I go back and I take what we had in here before and I comment all this out again, all right, commented all of it out, and I run the program again, it still works. The only thing we can't do now is actually instantiate an instance of the animal class. All right? Now, if somebody, let's assume that in our bird class, let's assume somebody else comes in here and they write this method. There's something, whatever it is, there's something special a bird can do. And they write this big, long, hairy-winded method that's hundreds of lines long. Okay? And now I'm over here as a user, and I want to be able to write the name of the bird dot that method. Can I do it? The answer is yes. Would I have any idea of how it works? Probably not. Would I care? Probably not. All right, this goes into another reason that you do all this stuff, and that is because projects of any magnitude are going to be written by multiple people. And since they are, all right, since they are, you're not going to understand everything that's in there. You just have to know how to use it. So the details are abstracted from you. My dad used to always make jokes growing up because I was the one boy in the family that really had no interest in learning about cars. Just my makeup. All right. He was a chemical engineer and he worked for an oil company. So guess what? We never got to go and get our oil changed. We had to change it ourselves. That I learned how to do. But I didn't really care. And, so some of the stuff that matters to me won't matter to other people, etc. But again, people become experts on typically some things, but not on everything. So if you were to ask me, for example, okay, I got in my car this morning, I wasn't backed in, so I put it into reverse, and I put my foot off the brake. If you ask me what happened internally to make that happen, don't know, don't care. I do care if I put it in reverse and I go forward, because I go right into my garage with the door shut. I wouldn't like that. But what I'm telling you is what happens in there has been abstracted from me. So why am I telling you that? Well, this leads to the last thing that I want to mention for now, and that is what are called the 4 pillars of object-oriented programming. They are abstraction, encapsulation, inheritance, and polymorphism. And believe me, you've already seen most of these. But let's just talk about them. The first is abstraction, and it's also known as data hiding. And I already told you, if I give you this program, all right, and I've got methods that actually do the bird and the dog, real methods, and you know how to call them, but you don't know how they work, do you care? Probably not. Unless you have to go in and change them. All right? That's abstraction. That's hiding the implementation and only showing the user the interface. Does that make sense? I gave you this example yesterday or the other day that if I come into a calculator and I type in 23, and I thought one of these was for square root, but if it is, I don't know which one it is. Maybe it's that one, I don't know. But the point is, I don't know how it did that. That's been abstracted or hidden from me. I see the interface, the implementation is hidden. And the main reason for that is you hide the implementation in case you ever have to change it. Because if the interface doesn't change, you typically change the implementation because that makes the project work better. All right? So that is the first of those pillars. The second is real close. So encapsulation is the binding of data and functions together to keep them safe from outside interference. What the hell does that mean? Well, if you remember yesterday when I said if I could define object-oriented programming in a nutshell, it's using private variables and manipulating them with public methods. All right, well, if we go back here and we look at our code, and I go into animal, these things can only be changed with those getters and setters. I'm encapsulating. I mean, when you think about what is a capsule, you know, if you have a cold capsule, if you open it up, it's got a lot of little things inside of it. It's kind of what we're doing here. We're putting a shell around it or whatever you want to say. Encapsulation is very much related to data hiding and abstraction. All right. Inheritance we've already looked at. Now, notice in here it says there are different ways in which inheritance can be done. This language supports single inheritance, meaning there can only be one parent. You cannot have something like this. So I've got class 1 here, and I've got class 2 here. And now I've got class 3. You can't do that. There actually is a name for that. It's called the diamond effect. You can't do it. Now, in a language like C, like not C sharp, but C++, you can do that. You can have more than one parent. In this language and in Java, you cannot. There's only single inheritance. And you can have hierarchical inheritance. So again, we could have come in there and said, let's use a different example. So we could say vehicle, car, truck, motorcycle. Then we could break them down. Harley, Kawasaki, etc. And we could break those down. You see what I'm saying? So you can set up a whole hierarchical arrangement. I took a class many years ago when I was working in Wisconsin, and it was in downtown Milwaukee. And the guy who taught the class worked for Johnson Controls. You might not have any idea what Johnson Control is. They make most of the thermostats, or they're one of the leading thermostat makers in the world. All right. And he said they were given a project that originally was supposed to take 2 years, that they were in their 5th year on it. All right. What they wanted to do was to rewrite all their code using object-oriented programming. And they used a hierarchical type of inheritance. And I was talking to the guy during the break. I said, well, how many levels deep is it? And he said, we're at 500 levels deep right now. So you can see how granular. It's like writing an outline for a book where you've got Roman numeral 1, then you've got your ABCs, then your 1, 2, 3s, then your ABCs in there, etc. It's the same type of an idea. So the other one that's left is polymorphism. Okay? And believe it or not, you already know that. If, in my animal class, the way we did this originally, we had in there for the speak method, all right, we had in there, I am speaking, or whatever the heck it said. Hello, whatever you want to put in there. If I made hundreds of different classes and I had them all from animal and I didn't change the speak method, they would all say that. Would you agree with that? But we could go in and we could change dog. So it said woof woof, cat, so it says meow. So we have different types of objects that are responding differently to the same method call. Does that make sense? That's polymorphism. All right. Those are the 4 pillars of object-oriented programming. Now, I've got a question for you. Everybody who's in here right now, how many of you do not have either a hard copy of the book or a PDF of the book? How many of you have neither one of those? Is there anybody? All right. Because I want you to understand this stuff. So what I'm going to ask that you do, I'm going to give you the rest of the period today, and I'm going to give you some time tomorrow to work on it too. But at the end of the chapter of the book that we are using, whoops. Where are we here? I tried to print it, it didn't want to let me. But at the end of the chapter, we haven't been doing, that's nice. We haven't been doing any of the exercises. We're going to do one today. I'm going to have to send you some of the starter material, and I'll do that in just a minute. Come on, continue reading. But on pages 407 and 408 of the book, they want you to go back to this product maintenance thing that we were doing, and they want you to add a customer class. All right? And it says here, in this exercise, you'll create a customer maintenance application that uses 3 classes. To make it easier to develop, and I'm going to give you this, I'm going to send it to you in just a minute. It says we'll give you the starting forms, a completed validator class, a complete customer DB class, and you'll have to do the rest. All right? You're not going to turn this in, and we will go over it tomorrow. But I just want you to get some practice doing it. All right? So it says, note the customer DB class assumes that the files of customers is going to be in this directory. So you're going to have to change that because that won't be your directory. All right? You can just put it on right in your C drive if you want to. But okay, if you place this file in a different directory after downloading and installing the files in the book, you'll need to change the path specification. You'll know it's wrong real fast when you try to run it if you get errors. All right? So it tells you to come in, open the project, and add a customer class. It's got 3 things in it. This is real similar to what we just did. But what we just did had what? It had a code and a description and then a price. Now we're going to have a first name, a last name, and an email. They'll all be strings. So it's even easier because we don't have any validation to do other than does it exist or not. The get display text will be basically the same as it was last time. Except in here, again, we're going to be passing in an email for the 3rd thing. All right. When you complete the customer class, use the Solution Explorer to review the members and jump around. Yeah, you can do that. Create a class diagram. All right. Then add the code to implement the add customer form. So it's good. The code is going to be virtually identical to what we just did for the add product form, but you'll have to change the field names and one type. Does this all make sense to everybody? All right. And then add the code to implement the customer maintenance form, run and test. So I'm going to send this stuff to you. It'll take me about 5 minutes to find it, but then I'm going to send you the starter files. And I'm going to ask that you try to do it. And I'm not going to lie to you. First of all, you're not turning it in. I'm not going to go and look at anybody's. But you can go out to Muroc's website, I believe, and download the answer. I don't know why you'd want to do that. I don't see how that helps you. All right? But if you get it done and you go, oh, I just want to see before class tomorrow, I think you can go out to Muroc.com and probably get it. I don't even know that for sure, but I think so. I get an instructor's CD. In fact, I don't even get the CD anymore. They just give me a link to their website. So I've got the answers already. I'll do it myself tonight and see if I get what they got. All right? You don't have to do exercise 12.2 because they ask you to redo it as a structure. No, we're not going to worry about structures now. But I'm asking you to try to do 12.1. And I'm telling you that I am going to go in and find that information. It'll be sent to you within the next 10 minutes. Questions? And then whenever we finish that tomorrow, we're going to start writing our own application from scratch.